In this video, we have an example of using node voltage to solve a circuit. This is actually a circuit that we solved before using just Kirchhoff's laws, and you can compare what we're doing now with node voltage to what we did before, see which method you prefer. So the way node voltage works, again, we took a look at our thing, we look at all the nodes we have. You can go ahead, there's one node, and then there's a second one that's obvious, is node 2. Then you can go ahead and consider this and this as nodes 3 and 4 here. However, I do want to point out something. If you look at the bottom node here, it is connected to two different voltage sources, the 5 volt and the 3 volt. And as we saw when we were introducing node voltage, by choosing this node to be ground, we will immediately know the two nodes here. Now, if I want to be really careful, I'll call it V1, V2, and V3. And so then if you look at this, since I'm at 0 for ground, and I have a voltage gain of 5 volts here, that means V1 is 5 volts, and we get the value of V1 right away. On the other hand, I'm at ground here at 0, and I'm going to have a voltage drop of 3 volts. So V3 is a negative 3 volts, and we can get those without having to actually solve any equations there. So I'm only going to need one node voltage equation in the middle here. And as always, it's voltage you're at minus voltage you're not at divided by R. So if I want to look at the left side here, voltage I'm currently at is V2 minus voltage where I'm going is 5 over 2. Then if I look at the middle branch going down, voltage I'm at, V2, minus voltage I'm going to, ground, is 0 over R, 8. And then finally, I have voltage I'm at, V2, minus voltage I'm going to, negative 3 over R is 4. We go ahead and set this equal to 0 here. I'll go ahead and clear denominators by multiplying everything by 8. On the first one, 2 goes into 8 4 times, so I'd have 4V2 minus 20. 8 cancels 8, gives you V2. And then 4 goes into 8 2 times, 2V2 minus a negative, it goes to plus 6 equals 0 here. I can combine 4, 5, it looks like I have 7V2. And 6 minus 20 is negative 14. I move it over, it's going to be 14. So my V2 would go ahead and be 2 volts. Now, when you're labeling node voltages, you're just creating new variables V1, V2, V3, and so on. And I'm trying to use capitals here, although it's maybe not as obvious that I'm using capital V, because capital V1 is not going to be the same thing as little v1. And capital V3 is not going to be the same thing as little v3. However, it does happen to be that V2, lowercase v2, because it's the voltage potential difference between the top middle node and the bottom node here, it's going to be the same. So we can write this out here. So my little v1, it's the voltage difference between these two sides here. So on the left side, we have capital V1. On the right side, capital V2. So V1 is going to be 5 volts minus 2 volts. So little v1 is 3 volts here. V2, again, it's the capital V2 minus the ground, which is 0. So V2 is 2 volts. For V3, V3 is going to be the positive minus the negative. Capital V2 minus capital V3 is going to be 2 volts minus a negative 3 volts. So V3 is 5 volts here. Then if we want to go ahead and figure out our currents here, my I1 is going to be little v1 over 2 by Ohm's law. That's going to be 3 over 2 or 1.5 amps. My I2 is going to be little v2 over 8. That's 2 over 8. It's going to be 0.25 amps. And lastly, my little I3 is my little v3 over 4, which is 5 over 4 my little I3 is going to be 1.25 amps. You can also double check here that it does satisfy Kirchhoff's current law. You have 1.5 amps coming in, and then one branch going out 1.25 and the other 0.25, so it adds up to the 1.5 coming in. And this is our method here. Notice that we really only had to solve one variable equation at a time here. We didn't have to break it down to, I think we had, solving this Kirchhoff's laws, we would have had 6 variables and 6 equations. So just by using this node voltage technique, we can really simplify things on these problems.